Hello dear students. In this video, we will learn what is pop operation on stack. Of course, in the previous video, we saw how to push a new value in the stack. That was quite a big video. Now, pop means we are removing a value from the stack. And whatever value we remove, we are going to return that value back to main. It will be important, first of all, to see how is pop called from main. So let's go on top and see the menu driven main, in which you can see the call to pop function. Just check, we are calling the pop function. And while calling the pop function, we are passing again the address of s. Remember, s is a variable of type stack which contains only one pointer called top. And pop is going to remove a value, correct, from the stack, and it is going to return the value. The value which has been deleted or removed is going to be returned, and it is going to be stored in an integer variable z, and then we are going to print the value popped is %d z. But some more things are there in this case too. Case 2 is for delete or pop. If we try to pop a value, just check, we are trying to pop a value, then it is important first of all to check, is there anything to pop or is the stack empty? Now it can happen, it can really happen that we have called for pop operation and the stack looks like this. S is the stack which has top pointer, and this top pointer is null. What that means is that there are absolutely no nodes created yet, absolutely no nodes created, or there doesn't exist any nodes in the stack because top is null. This is known as stack underflow. Stack is called underflown if stack is empty. And really here s dot top, as you see, is empty, isn't it? So stack is underflown. Don't you feel that before you call this pop operation, it is better to check that if empty stack, don't worry, I'll tell you what this function is. But if empty stack, then print there is nothing to pop. The stack has underflown, correct? But if this condition is false, that means if the stack is not empty, only then go to else and call the pop operation and then print the value that has been returned. So although this video is about pop operation, but there comes a companion in this video. The companion is empty function, because this empty is a function which will check whether the stack is empty or not. I repeat, this empty is a function that we have defined below. This empty function will check whether the given stack S is empty or not. And if it is empty, it is going to return true. Yes, it is empty, isn't it? So it returns true. And true means 1. We are going to return 1. But if the stack is not empty, then this function empty is going to return false. Stack is not empty, it's returning false. And false is 0. So this function empty either returns 1 or 0 depending on whether the stack is empty or not. How do you write this empty function? Just check the empty function written at the bottom here after push function. The empty function returns int. Why? Because you know it's going to return either 1 or 0, which is an int value. And 1 means true, that the stack is empty, and 0 means false, that the stack is not empty. And the empty function, as usual, is getting address of s. You might have seen the call to empty. It was called as in the if. It was called as if empty. This is the call to function. Address of s. Address of s is passed. Correct? So the empty function is taking the address of s, and address of s is as usual copied in the pointer p, which is of type stack. For some time, to understand this empty function, you assume that the stack is really empty. That means top is null. Then you know that this pointer p, which is now pointing to s, because p stores address of s, as you see here, p stores address of s. We will now ask a simple question. If p arrow top, which is this top which I am underlining in the picture, p arrow top, is it null? Oh yes, it is null at the moment. That means the stack is empty. So the function returns 1. 1 means true. Stack is empty really. Isn't it so? So empty function is very easy. Just inspect the value of top. If top is null, simply return true. Otherwise, return 0. When will be 0 returned? That is false returned. Imagine that we have pushed some values in the stack and stack is not empty. In that case, the stack is going to look like this. S is containing top, and maybe top is pointing to 30, and 30 has next, and this next is pointing to 20. 20 has next, and this next is pointing to 10. 10 has next, and this next is null. What you see is top is not null here, isn't it? Top is pointing to 30. That means P arrow top, this top, equal to null is false. So the function is going to return 0, which is false. What that means is false is returned means stack is not empty. So come on, tell me, how do you call pop function from main? It is very risky, isn't it, to call pop function without inspecting whether there is anything to pop or not. So whenever you are interested in removing a value from the data structure, you can see you just ask if stack is empty. Simple words, isn't it? This is what it does. And if the stack is really empty, it will print stack underflow and not go to else, because if it's true. But what if this condition is false? That means stack contains a few values. Then it goes to else and calls pop function. The pop function takes the address of s, removes the topmost value, and stores the returned value in z, and finally prints the value of z. I hope you have understood importance of empty function. Very important, isn't it? Now let's inspect the pop function. How to remove a value from the stack? Remember, pop takes the argument as address of s, and s has been written in the bracket. So let's scroll down and let's see the pop function. Okay. So to understand the pop function, first of all, let's imagine a stack like this, which is not empty, of course. Stack should not be empty. Let us say s top here points to 30, which has next points to 20, which has next, and next points to a node which has 10, which has next, and this next is null. So as you know, all these are nodes. So come on now, you just inspect this pop function and just see how these statements will get executed, isn't it? Now observe that this p stores address of s, because that's the parameter passed. So p points to s. We have declared one local variable x. So x is a new variable I am writing down here. And what we are doing is we are saying p arrow top arrow data. Just check this p arrow top arrow data. What is p arrow? First of all, p arrow, just check p arrow top, p arrow top arrow data. That means we are talking about 30, isn't it? Just follow the pointers. P arrow top arrow data is nothing but 30. And that 30, this is 30, will be stored by the local variable x. So x is 30. And our plan is that we are going to return this x. Check the last line. We are going to return this x back to main. But then after making x equal to 30, the next line is very important. P arrow top equal to P arrow top arrow next. Just check this line. That means P arrow top, check this again, P arrow, this one, P arrow top should point wherever P arrow top arrow next points. But P arrow top arrow next points to 20. That means the pointer P arrow top should no more point to 30, correct? But it should point to 20. And exactly it should be done because remember we are deleting 30, we are popping 30. Then top points to 20 now. We could have added one more line here before return x. Before return x, we could have written free that particular node. We could have written that, but no need of writing it because although you don't free this from the RAM, but then this node is of no use now. This node is lost. This node is lost. How come? This node is lost because there is no pointer pointing to it. And you see the top is very well pointing to 20. So your stack starts from 20 and 20's next points to 10 and 10's next is null. So if you are asked now, which are the values in the stack? The values in the stack are 20 and 20 has next pointing to 10. That's it. And finally we return this x which is 30. So 30 is returned back to main. By the way, if you execute pop function again, pop operation again, what will happen? What are the values in the stack now? Only 20 and 10, isn't it? So we have 10, its next, as you all see, are null, and we have 20, its next is pointing to the node which stores 10. And we have S, whose top is pointing to this 20. Now, if you start the pop function, again P stores address of S. So P is pointing to S. Now watch, X is again equal to P arrow top arrow data. Now P arrow, follow the pointers, P arrow top arrow data. This data 20 we are talking about. So X becomes 20. And then this line P arrow top should now change. P arrow top should change to P arrow top arrow next. But P arrow top arrow next, observe, is pointing to 10. So this top pointer will not point to 20, but it will point to the node which stores 10. I hope you are understanding. Now you see this top pointer is pointing to 10. That means this 20 is as good as deleted. It is of no use now. It is lost and our stack starts from 10. This is how the pop function has been designed. Yes, I agree. We should have added one statement called free and we should have physically removed this 20. But even though if you don't remove this 20, it will be removed. I mean, it is of no use, although it is there in the memory. Maybe in the later videos, when we implement Q, we will make use of this function call called free in those videos. That's how pop works. I hope you have understood, and empty function also. Thank you very much.